All right, so we started talking about end behavior yesterday. End behavior, where the graph goes as x goes to infinity, negative infinity. All right, so we figured out that for the first one, it's a degree 3 with a leading coefficient of 1. That means that it's an odd degree, and it's positive coefficient. So this is what our end behavior is going to end up looking like. So as x gets really, really large, y values are going to get very large. As x gets really negative, y values will get very negative. All right, so what you want to do is kind of get a general idea of what it's going to look like around the middle there. So just kind of plug in some points to get your values. All right, so if I plug in 0, what do I get? We're on 2a. You get 0. Okay, if I plug in 1, what do I get? If I plug in negative 1, what do I get? So you get negative 1 minus negative 1. All right, if you plug in 2, what do you get? You get 8 minus 2, which is 6. And then if you plug in negative 2, you get negative 8 plus 2, which is negative. All right, so I would put all those points kind of on the graph. So you have 0, 0, 1, 0, negative 1, 0, 2, 6, negative 2, negative 6. All right, so we have 2, 6, which is do the best you can. All right, so once you guys have your points, just kind of draw the curve the best that you can. I know. Well, I mean, for right now, this is kind of the best way to do it. As we work through the chapter, you'll figure out new ways to better graph a polynomial. But for right now, just kind of plug in some points kind of around 0, and then use your end behavior to kind of come up with the rest of the graph. Right. So as x gets really large, y values get very large, and as x gets very negative, the y values get very negative. sure I tag you. Put your shoe stuff with it. All right, what's the degree here? And the leading coefficient is 1, right? So that means we have an even graph, positive leading coefficient. So that means as x is going to go towards infinity, where is f of x going to go? Infinity. And then as x goes to negative infinity, f of x will go towards, right? So they're going to be both going kind of in the same direction. Yes. That's what we did yesterday, like with the different graphs on the iPad. Think of, you know what an x squared looks like, right? Right. All right, so it looks like that. And then do you know what an x cubed looks like? Kind of like that. All right, so any polynomial that's an even power is going to look like very similar to this. It has kind of the same properties as an x squared. And then if it's an odd power, it's going to look very similar to that. So that's really the only two graphs that you kind of need to memorize. So as x gets more and more positive, so as x goes to the right, your y values are going up, right? So they're going towards infinity too. And then as you go to the left, your y values are going up, right? So that's why you say as x goes to infinity, if the leading coefficient is positive, yes. And it's even, right. Right. If this was negative, then it would be going down. No, they'll both be going down. Then they go in like opposite directions. So like if it was odd and positive, as x goes to infinity, the y values go towards infinity, and then as x goes to negative infinity, the y values go to negative. And then if this was negative, it just switches because it's just a reflection over the x-axis. Right. And these are pretty much the two general shapes that you need to know. Either an even graph or an odd graph. All right, so if you plug in 0, what do you get? 4. If I plug in 1, what do I get? 1 minus 1 minus 4 plus 4. That would be 0, right? 1 minus 1 is 0. Minus 4 is negative 4 plus 4 is 0. Plug in negative 1. I got 1 plus 1 minus 4 plus 4. So that would be 2. I would do like 5. You plug in 2. 2 to the 4th would be what? 16. Minus x cubed, which is 8. Minus 4x squared. That's 16. 2 squared is 4 times 4 is 16. Where are you getting 64 from? Alright, so the 16s cancel out, and then you got negative 8 plus 4, which is negative 4. And if you plug in -2, you get 16 plus 8 minus 16 plus 4. That'll be what? You're right. Yep. All right, so let's see if we can put those points on. So we have 0, 4. And then we have 1, 0. And we have -1, 2. I got 2, -4. And then -2, 12. Just kind of like up here. All right, so as I spread out more and more this way, where should the graph generally go? In what direction? Going up, right? Because they're both going to go towards infinity. So the outer edges of your graph should be pointing in that direction. Well, that one you might just have to like come down and then go back up like that. So you could do something like this, go down, up. That's a 4th degree graph. The higher degrees that you get, the more, it gets more hilly and valley as you get in the middle here. What is it? Wombo. Again, you got to use your end behavior to get the general idea of what the graph is. This one here, it's like -2, 12. All right, so again, as x goes to infinity, the y values go towards infinity. As x goes to -infinity, the y values go towards positive infinity. All right. Stuff. We all right. Are we good? All right, so next problem says sketch a graph for the polynomial function having the following characteristics. So f is increasing when x is less than 0 and x is greater than 4. F is decreasing when x between 0 and 4. F is positive between -2 and 3 and greater than 5. And then it's negative when it's less than -2 and between 3 and 5. Okay, so you have all those different properties, and you want to try and fit the graph that meets that, right? So you're going to have, there's really a number of different ways you can do this. What I kind of feel is the best way to go about it is you want to use these 2 points here and kind of tell the story of how the graph is coming about, right? So go from kind of left to right, and then kind of connect that with the first 2 points that you have here, right? So out of these first 2 points, as I'm going from left to right, where am I going to start first? So you have less than -2, -2 to 3, 3 to 5, and then greater than 5. So where would I start if I'm going from left to right? Right. So what I want to do is I want to start here. F of x is less than 0 from x is less than negative 2. So f of x. All right. What do we know? We know that the graph needs to be less than 0, so that means it needs to be negative, so that needs to be below the x-axis. Yeah, that would be a y value. Yes. It is yes. All right, so f needs to be negative, or the y values need to be negative. Go with that. Negative. Now, what do we know about what's the graph doing when x is less than negative 2? Is it going up, or is it going down? What does it say here? F is increasing when x is less than 0. So that means that the graph is going up until you get to x equals 0, and then you have to change direction. Huh? Yeah, this is like the location, right? All the x values less than 0, right? So y values need to be negative, and the graph needs to be going up. So graph. All right, so we did that part. What would the next piece be? Right. And what does it tell you between negative 2 and 3? It's positive, right? So you could say negative 2 is less than x, which is less than 3. So you know that the y values need to be positive. Okay. Now what else do we know? So look for in between this interval. So it looks like x is less than 0. So right up until I get to about 0, I still need to have the graph going in upwards direction. So graph goes upward till 0. And then what does it do once it gets to 0, what does it start doing? It starts decreasing. So now it's going down, right? So I need to be going down until I get to 3. So then graph goes down until 3. All right, so we did the first two. All right, so let's do these first two pieces. So the y values are negative, and the graph needs to be going up when x is less than negative 2. Right. So I have negative 2 is right here. Okay. And it says the y values need to be negative, but the graph needs to be going in an upward direction. So less than negative 2, which is over here. So the y values need to be negative, which is down here, and the graph needs to be going up. All right. So kind of draw yourself this graph kind of looking like that. And then from -2 to 3, so -2 and then 3 is like right here. The y values need to be positive, so all your y values need to be above the x-axis here. And then it needs to keep going up until you hit 0, and then it needs to start going down once you get to +3. So you can do, keeps going up until you hit the 0. Now it's going to keep going down until you hit 3. All right, so we're increasing. Now we're decreasing from 0 to 3, and then I need to start probably going up again. See how it says f is increasing when x is less than 0. So you want your graph to be kind of going in an upward direction until you get to x equals 0. Right? And then it needs to be decreasing between x equals 0 and 4. So it needs to be kind of going down from 0 to 4. And then once you get to 4, you want it to go back up again. Yeah. So that's what we figured out so far. We've done from less than -2, and then between -2 and 3. So what would the next piece be? Right. So now I want to do from 3 to 5. So 3 is less than x, which is less than 5. All right. So what do we know about? What does it say the y values have to be? Less than. So that means that they need to be negative. So y values are negative. And then I need to keep going down until I get to 4, and then once I get to 4, what do I need to start doing? Going back up again. So you could say decrease until 4. And increase after. All right, so then from 3 to 5, which is right, 5 is right here. So I need all my y values need to be negative from here to here. And then where do I have to change direction at? 4, right? So you can kind of come down like this and then go up. I'm going to go down like that and then come back up. All right, so we did that part, and then the last part is you just got to fill in the rest. So it needs to be positive when it's to the right of 5, and it needs to be going in which direction? Because it's increasing. So then you just fill in like that. All right, so that could be one general graph you could do. This part right here is telling you that your y values need to be positive, and then this part here is telling you that the graph needs to be going in an upwards direction. No, we kind of already did that when we did like this one, and this one. What's that? So I would do, when they tell you these two, I would put these two like in order. So we started with this one, and then we moved here, and then moved here, and then moved there. So we put it in sequential order. And then just kind of see, okay, x is less than -2. Where would that fall into here, here, or here? So obviously, x is less than -2. That's going to fall into that interval. And then just go in order. All right, and then we went from -2 to 3. So that would fall into here and then there, right? Because 3 is in between 0 and 4. And then the next one was from 3 to 5. So that's 3 falls in between here, and then 5 would fall into that one. All right, so this is f is decreasing, increasing, greater than 0, less than 0. All right, so let's put it in order. So as I go from left to right, what would I hit first? Right, so this would be part 1. So x is less than -3. So what do you know, what is the graph doing when it's less than -3? So the y values need to be positive, right? Y values are positive. Always go from left to right. So, think of like a number line, and the left, the leftmost number. Yeah. No. All right. So what do we know? X is less than -3. What's the graph doing? Is it going up or is it going down? Going down, right? All right. So graph is moving down. Because that comes from that part right there. So if this was less than 0, you can say the y values would be negative. So the graph would be looking like this, like y values are positive, but they're moving down. So it looks like that, right? All right. So what would be the next piece? Right. Good. So we know -3 is less than x, which is less than 1, right? We know it decreases until about -1.5. So it decreases until x equals -1.5. And then what does it do from -1.5 to 2.5? Goes up, right? So that falls somewhere at the back end of this interval here. So I need to be going up until I get to +1. Okay, we'll increase. And what do we know the y values are going to be from -3 to 1? Negative. So y values are negative. Okay, so y values are positive, graph is moving down, and then decreasing decreases until negative 1.5, and then it starts increasing again. So at negative 1.5, you're going to have a change of direction. So it's going to go down like this, and then once you get to negative 1.5, change direction. Yeah, but it decreases and then starts to increase. Yeah, so it kind of goes like that. All right, so this is negative 1.5, right? And then 3 is right here. So we know that it's positive and decreasing. And then at 1.5, I need to kind of change directions. And I know that it's going to be increasing until positive 1. So positive 1 is like right over here, so I'm going to go up kind of like this. So this is negative 1.5, and this is negative 3. So again, we're positive and decreasing, and then at negative 1.5, we change direction. So much easier with calculus. Okay, what would the next piece be? Okay, so 1 is less than x, which is less than 4. So we know our y values are, and what else? So we know that my graph is increasing until about 2.5, and then at 2.5, I need to change directions. So change directions at x equals 2.5. Increase to decrease. Okay, so 4 is over here. This is positive 1 right now. This is negative 1.5. And then at 2.5, we need to make sure that we change directions. So it's going to be going up, and then at 2.5, I need to change direction. Yes. Yep. 4. That's 2.5. That's 1. Negative 1.5. Negative 3. And then what's the last piece? So x is greater than 4. What's the graph doing? Going down. Says if x is less than 0 when x is less than 4, so your y values need to be negative, and then decreasing, because this interval fits into that one. All right, so that could be one general graph for